Hey guys, so this is Chris, and I'm doing the life and death of a star. Okay, so to start off, every star is born in a nebula, and it's kind of this high density place of dust particulates. And in these nebulas, there's millions and trillions and trillions and trillions and trillions of little dust particles that kind of float around and do their thing until gravity acts on them and pulls them towards a center. And this is where a sun's protostar stage begins. During this phase, gravity acts on all of these little particulates that are kind of floating around, and it does this until the particulates are dense enough to have a force of their own to work against the gravity. And all the while, these little dust particulates are kind of floating around. There's these hydrogen particulates that are also in there that are colliding with each other and crashing into each other to form hydrogen. Helium forms helium, which grows exponentially. And it does this by a means of nuclear fusion, which is essentially what makes a protostar a protostar. It's when the heat rises due to hydrogen and hydrogen making helium. So, the protostar actually gets extremely, extremely hot, as in 15 million degrees centigrade hot, which is equal to about 27 million degrees Fahrenheit. And after it's reached this threshold, it becomes a main sequence yellow or a main sequence blue, which we know the yellow are the smaller and the blue are the bigger, and ours is a main sequence yellow currently. So to start with the smaller stars first, as a star goes through its main sequence, it actually gets brighter. Please ignore my creepy drug-addicted sons. They kind of look like they're methed out. But as a star progresses, it becomes brighter, which is actually a bad thing, so I don't really know why they're happy, because it actually means they're going to die soon. And to put it into perspective, our sun, in about 1.1 billion years, is going to be 10% more luminous than what it is today. So, when the helium core is finally reached, hydrogen is zero, carbon begins to be formed around the outer shell. So you've got this helium core surrounded by this carbon shell, surrounded by this luminous shell, and this is essentially when the layers begin to expand. However, gravity is still acting upon them, so they're not just going to explode or anything. So when you used to have this kind of condensed small star, you now have this larger star that begins to dim a little bit, but is known as a red supergiant or red giant. And the dimming from the stars is caused by the cooling. However, cooling is a relative term because it will still melt your face off. Eventually, helium will run out. And when it does this, that outer layer right there will begin to expand. And it'll do so slowly. It won't explode, it will just kind of slowly, it'll appear to be slow, but it'll expand, and that's where you see a lot of the galaxy pictures, kind of the explosions of color and the circles that they make. It's planetary nebulas, and it's a result of smaller stars dying. So the inside, right there, the core, is actually a white dwarf, not dwarf. And that teeny tiny, well, relatively teeny tiny star is 80% of the original star, which was much bigger than when it started out. But due to gravity, it has condensed. So that kind of ends the small star's life, but large star's process is the exact same thing as a small. However, after the red giant, it continues to form larger elements, heavier elements, up until it has an iron core, which stops the cycle completely. So, a larger star, because it has more energy, will fuse heavier elements all the way up to iron. So it'll go through hydrogen, helium, lithium, beryllium, all the way up until iron. And when that iron core is reached, it collapses due to gravity in a matter of 1 second. And in that 1 second, everything happens at once. So you have this iron core, right? And it kind of radiates outwards, and this is what's known as a supernova. And it sends shockwaves outward that then blast the outer layers outward, destroying everything in its path. And from our perspective, depending on how close or far away that star is, what once was kind of bright might seem just a little bit more bright, or it might seem incredibly bright, just because of how much energy is being produced. However, there are stipulations. If, let's say, the star weighed like an exponential amount, like something really crazy, then the resulting surviving star from the supernova would become a neutron star, which is a minute fraction of what it used to be, and is extremely dense and heavy. And if that neutron star is 3 solar masses, which is actually like 3 of our suns, it collapses in itself and becomes a black hole, sucking in everything, even light. Which is essentially how a star dies. Which brings us to the end of our video. Thanks for watching.